Betelgeuse is a gigantic red supergiant located in the Orion constellation. It has fascinated humanity for centuries with its intense reddish glow and enormous size. Astronomers have estimated that if Betelgeuse were situated at the heart of our solar system, it would engulf all planets up to Jupiter. This star's vastness signifies that it is nearing the final phase in the life cycle of stars like it, preparing to culminate in a catastrophic explosion known as a supernova. In recent years, however, Betelgeuse has exhibited extraordinarily unusual behavior. Its luminosity surged by more than 50%, launching it from the 10th to the 7th brightest star in the night sky. This sudden burst of brightness left scientists scrambling for answers. Was this an early warning of its explosive demise, or merely a temporary blip in its life cycle? The potential effects are enormous. If Betelgeuse were to explode, it could make the night sky so bright that it would appear as daytime, providing extraordinary scientific opportunities. A star's size affects its brightness, temperature, and distance from Earth. Betelgeuse, with a size over 700 times that of the Sun, is relatively cooler, with surface temperatures ranging from 3000 to 3500 Kelvin. This gives it its signature red hue. Because of its massive size and low temperature, Betelgeuse is a prime candidate for a supernova, making its recent behavior even more intriguing. Betelgeuse stunned astronomers once more in late 2019 by dimming to 40% of its usual brightness. This significant change, visible even without telescopes, prompted widespread observations and debate. Some speculated that dust might be obscuring the star, while others considered internal processes at play. The possibility of an impending supernova became a major topic among experts. Using the Very Large Telescope (VLT) in Chile, astronomers captured detailed images of Betelgeuse during its dimming stage. These images revealed that the star had taken on an obvious lopsided appearance, suggesting that the dimming was likely caused by a massive surface mass ejection (SME), during which Betelgeuse expelled an extraordinary amount of material into space. This unprecedented event altered the star's life and disrupted its pulsation cycle, comparable to a volcanic eruption but on a cosmic scale. Over 400 billion tons of material were ejected, significantly more than typical solar events. This upheaval not only changed the star's appearance but also shortened its 400-day expansion cycle to just 200 days. These radical changes indicated that Betelgeuse was becoming more unstable, leading astronomers to question how long it could maintain its current form. Because of this volatility, astronomers intensified their monitoring efforts, eagerly looking for evidence of an imminent collapse. When a massive star like Betelgeuse exhausts its nuclear fuel, its core collapses under its own weight, causing a supernova. This massive explosion releases an immense amount of energy, blasting the star's outer layers into space and creating a dazzling light visible even during the daytime. Should Betelgeuse explode, the first signal would be a burst of neutrinos, tiny subatomic particles that travel faster than light and can escape the star before the explosion itself. These neutrinos would reach Earth hours before the light from the explosion arrived. When the light does reach us, Betelgeuse might shine more brightly than the full moon, illuminating the night sky for weeks. A supernova of this magnitude would provide an unprecedented opportunity for scientists to study stellar death in real time. By analyzing the emitted light, radiation, and heat, researchers could gather invaluable information about stellar evolution, the physics of nuclear matter, and the formation of elements essential for life. To understand Betelgeuse's unusual behavior, researchers are using advanced simulations to model the star's interior. These virtual models incorporate data from telescopes like the James Webb Space Telescope, JWST, and the VLT, allowing researchers to investigate the processes driving Betelgeuse's instability. Simulations suggest that a sizable gas bubble likely formed deep within the star, triggering the SME and altering its pulsation rhythm. Observations from the JWST have provided a closer look at the material ejected by Betelgeuse, unveiling intricate structures of gas and dust surrounding the star. These findings indicate that Betelgeuse may be approaching the final stages of its life cycle, offering a rare window into the life of massive stars. While scientists predict that Betelgeuse could go supernova within the next 10,000 to 100,000 years, its erratic behavior suggests the timeline may be significantly shorter. The astronomical community is racing to document every aspect of this cosmic spectacle before it reaches its dramatic climax, ensuring that humanity doesn't miss this rare event. In late 2023, the JWST, with its unparalleled observational capabilities, focused on Betelgeuse and discovered shocking new phenomena. Scientists found the star in a state of instability due to the massive ejection of its surface mass, which had triggered an immediate internal collapse. This collapse was indicated by significant changes in its core dynamics, altering the flow of nuclear fusion reactions. Astronomers observed dramatic fluctuations in Betelgeuse's expansion cycles before the collapse, with the star's surface expanding and contracting steadily over 400 days. Afterward, this cycle abruptly shortened to just 200 days, indicating significant disruptions in the star's internal structure. These irregularities served as a cosmic heartbeat, signaling that Betelgeuse may be approaching the end of its life as a red supergiant. Simulations conducted by astrophysicists reveal that the star's core is becoming increasingly unstable as it fuses the last elements before its inevitable collapse. Heavier substances. When stars attain this phase, they begin producing iron, a process that marks the final stage before collapse. Unlike other elements, when fused, iron does not release any energy, causing a buildup of mass that ultimately forces the core to collapse. Betelgeuse's recent behavior has sparked a frenzied discussion among astronomers regarding the supernova's timetable. While some contend that the explosion could occur within the next few decades, others believe it could be thousands of years away. What is clear, however, is that Betelgeuse's existence as a red supergiant is coming to an end. One of the key indicators that a supernova is imminent is a surge in neutrino activity, tiny subatomic particles that mark defining moments in a star's life. Scientists are closely monitoring Betelgeuse for any sudden spikes in neutrino activity, and instruments around the world are on high alert to detect this fleeting signal, which might supply humanity with its first real-time warning of an impending supernova. In contrast to other cosmic events, Betelgeuse's supernova will be an awe-inspiring celestial spectacle. Scientists assure us that it poses no danger to Earth. However, its brightness could rival that of the full moon, casting strange shadows and illuminating the night sky. This event will not only last for weeks, attracting stargazers, but also provide an unparalleled opportunity for researchers to monitor the death of a massive star in real time. The tale of Betelgeuse serves as a reminder that there are still mysteries throughout the universe waiting to be discovered. This enormous star, which has mesmerized humanity for centuries, continues to challenge our understanding of stellar evolution and the dynamics of the cosmos. Betelgeuse's dimming, mass ejections, and unpredictable behavior remind us of how much we still have to learn. Its potential to go supernova provides scientists with an extraordinary opportunity to study the life cycle of massive stars firsthand. Understanding these processes goes beyond determining the fate of a single star. It's about unlocking the mechanisms that shape galaxies, seed the universe with vital components, and even make life possible. This knowledge expands our comprehension of the universe's past, our place within it, and the tools we use to study it. Thanks to cutting-edge instruments like the James Webb Space Telescope and the Very Large Telescope, scientists now have access to technology that previous generations could only dream of. These advancements allow researchers to conduct simulations, study stellar dynamics, and peer billions of years into the past to gain a deeper understanding of the foundation of reality. For researchers like Neil deGrasse Tyson, these kinds of discoveries are both exciting and urgent. They push the boundaries of human knowledge and challenge us to keep exploring the cosmos. The next time you look up at Orion's belt, keep in mind that one of those points of light tells the story of a star nearing the end of its life. Are we witnessing the final moments of Betelgeuse before it explodes? Or is this just another stage in its enigmatic life cycle? Share your thoughts and join the conversation about one of the most intriguing stars in the universe. Betelgeuse's unusual activity is providing astronomers with rare opportunities to study the intricate processes that govern the evolution of massive stars. Every ejection of surface mass and every sudden change in pulsation patterns brings us one step closer to comprehending stellar life cycles. One of the most intriguing aspects of Betelgeuse's evolution is that it is in a relatively uncommon stage of its life cycle as a red supergiant. While Betelgeuse is nearing the end of its life, its journey to a supernova is not as straightforward as it may seem. The precise reasons for its irregular behavior are still debated by scientists. One of the most dramatic outcomes observed so far is surface mass ejection, which could signal the start of a more extensive series of changes leading to the star's eventual explosion. How fascinating is that? Betelgeuse's supernova might answer some of the most fundamental questions in astrophysics. The explosive death of a star like Betelgeuse holds the potential to reveal insights into the nature of dark matter, the expansion of the universe, and the processes that lead to the birth of new stars and planets. These revelations could help scientists refine current models of the cosmos and gain a deeper understanding of the universe's evolution over billions of years. Betelgeuse is part of a broader international effort by the astronomy community to comprehend the life cycles of massive stars. Studying stars like Betelgeuse helps scientists learn about the final stages of stellar evolution, which are notoriously challenging to monitor in real time. Most stars die in ways that are extremely distant and difficult to observe, so when a star like Betelgeuse begins to show signs of its final explosion, it presents an exceptional opportunity to study this cosmic process up close. One of the remaining unanswered questions is how long Betelgeuse has before it finally reaches the supernova stage. The timeline for the star's death is still unclear, and researchers frequently adjust their predictions based on new data. Some astronomers believe Betelgeuse might explode sooner than expected, while others think it could take tens of thousands of years. Regardless of when it happens, excitement surrounding the star's eventual explosion remains high. For now, researchers continue to monitor Betelgeuse closely with a variety of sophisticated instruments. From ground-based observatories like the Very Large Telescope, VLT, to space telescopes like the James Webb Space Telescope, JWST, scientists are utilizing the latest technology to peer into the depths of this massive star. The data they gather will help refine our understanding of stellar evolution and provide insights into the forces that drive the universe itself. As the story of Betelgeuse unfolds, it serves as a powerful reminder of the vastness and complexity of the cosmos. The universe is full of stars undergoing extraordinary transformations, but few offer as clear a window into the final stages of a star's life as Betelgeuse. Its approaching supernova will be a monumental event, one that could help scientists answer some of the most profound questions about stars, galaxies, and the universe as a whole. While we may not yet know exactly when Betelgeuse will explode, one thing is certain: when it does, it will be a defining moment in the study of stellar evolution. Scientists around the world eagerly await this event, which will provide countless opportunities for exploration and advancements in our understanding of the cosmos. For the rest of us, it will be a reminder of the incredible beauty and mystery that surrounds our universe.